All right, guys, what's up? Over here at the shop, going to work on this thing for a little while. Going to go ahead and get the pistons off rods and go ahead and get the rings off tonight. Hopefully I can get this thing getting closer to going back together. But check this out. This is a set of CP bullets. The piston pin has 200 thousandths on this one. They make some in 250, 275. Some as thin as for the lightweight stuff, 140 thousandths. So you want to run a moderately decent sized pin if you're going to be doing any type of power adder, any type of blower, nitrous, or turbo. So forced induction is good. Something else to be careful of, pin height. Depending on what the pin height is from here to the top of the piston. So if you have a very thin package, and yes, this one I know somebody's going to ask, this is a off-the-shelf piston that's got a little teeny dome on it, and it doesn't have much ring land on it at all. I don't think these pistons were quite designed to go as fast as I'm going, but believe it or not, I hadn't really had any piston failures. So the tune-up is fairly decently safe. But going back to pin height, so a lot of times, if you have a long stroke or a long rod and you have a short deck height in the motor, then this pin may be up in the oil rail. So this could be, you know, it's not really that big a deal. Typically what happens is they will, it'll have a spacer in the bottom just so that it doesn't go into the oil ring itself, and then it's cut a little bit wider, and then the oil ring goes in there. This package here, these are 1.5, 1.5, 1.5, and 3 millimeters. So, you know, it's a pretty thin ring package. A couple benefits to having a thin ring package. You know, it creates less friction, so it should make more power. So the rings are pretty good. There are some thinner ones. Some of the race cars now, I don't know if they do it in the blower applications, but they have a .043 ring on the top. So that's a pretty good design. That's what a lot of people are doing. Now, one of the things that you'll notice here is these things have the little clips for the pins that hold them in. They don't have spiral locks, so they don't have buttons. Now, Randy's has got buttons, and I've never really used buttons before, but man, they are bad to the bone and so easy to do. So one thing to be careful of when you're putting these things together, always make sure this is what it looks like when it's in the motor itself. The valve releaser up top, the domes are down, you know, toward the bottom of the motor. So you always want to make sure you be careful on the way this rod goes on the piston. It makes a difference. The very flat part here, this flat part goes against the other rod, and you'll see on this other side here, this is a chamfered part. That's what goes against the crankshaft. So you got the crankshaft on this side, so it will go here on the chafer. This is the radius that is on the journal. So if you don't have that radius with the chafer, then, you know, it'll bind up. So if you put these rods in wrong, it will not spin over. When you tighten down the caps, it's going to lock down on it most likely. And you'll see the bearing is also inset from that. And there again, taking care of the radius. So the other rod will be here, and this goes off to the other cylinder. So this is just a basic layout. This is a set of good aluminum rods. You can see I didn't have much wear and tear on the bearing. It's not squashed it out anywhere. That's one of the things you can look at. You can tell detonation if this bearing is flat here. If the bearing is hammered and starting to go out and you're starting to lose material on the surface, which you can see it's scuffed a little bit, but it's not flattening at all. This is how you can tell if you've been detonating the motor any, if it's been hammering it. That's how you can tell, because what happens is the piston is coming up in the bore. So as the piston is coming up in the bore, you get that pre-ignition or the detonation, and then it's still coming up and it gets a sudden flame front instead of the normal flame front from the normal combustion coming up and then going down. What happens is it's coming up and then you get a high spike in pressure, and it tries to push it down as the crank is coming up, and it will actually hammer that bearing out and it will flatten it, and it's very easy to see. But these are good rods. I just had I'm pretty sure what happened on mine, the reason I had the failure is, you know, that lack of oil supply, you know, from using that spacer bearing. And I did decide, you know, I talked to a couple of people and talked to my machine shop, and we're going to glue that spacer bearing to that main bearing. So hopefully we won't have any more issues. But we're fixing to take this thing apart real fast. Check this out. Okay, so we got all the rings off. So this ring right here, this is the second ring. This is called a Napier ring. It's gonna be really hard to see it, but essentially these things have on the outer edge, so this would go down toward the crankshaft, but this right here is a very small, it's like a little bevel edge like this. It's like a scraper. Somebody mentioned in one of my other videos that essentially the second ring was an oil scraper, and that's exactly right. But one thing I have always heard is when you take these motors apart is if the rings are brittle, then they're still good. But if they've been overheated, they will bend and not break. And so this is that Napier that I was talking about. Let's see. And it's so difficult to see. I don't know if I'm gonna, you can kind of see that edge a little bit there. But it's like a scraper. It's like a wedge, and it just helps remove oil. So that's the second ring. So these typically don't get exposed to as much heat as the... What in the world is the matter with my focus? So these typically don't get exposed to as much heat. So it will break, and it's pretty fragile. So if I grab a top ring, now it could be a different material as well, but I bent one a minute ago. That's the second ring. Second ring. Do I have any top rings? Oh yeah, here's the top ring. And look at the difference too. If you look at the radial thickness, this is something that a lot of people don't look at. So every piston is going to tell you what the radial thickness is. It's just a smaller... The width of it, the top ring, is the radial thickness is different. So make sure, you always got to make sure that you get the rings that are right for your pistons. So this is a top ring. So let's see what happens if I try to break it. Now that one broke. So that one broke, so that one was not overheated. I bent one a few minutes ago. So this one, that's a top ring that was losing its tension. It was losing its seal. And the way it bent and stayed bent, that just means that that ring was overheated. And so the amount of force that it was able to push out on the wall was reduced. So there again, I think I put these rings in last season. I don't think they were all brand new this year. But anyway, got all the pistons off. They're all off the rods. So I've got my new rods. So this is part of the process on getting it ready to go back together. So I'm going to now, next couple of days, I'll come over here and clean the pistons really good. And then when I get the pistons cleaned up really good, I'll throw the new rods on the pistons. And here you can see these are CPs. Something else to look at when you're taking yours out and looking. I have seen various pistons down in this area here on the boss. It cracks. So make sure you examine your pistons good when you pull them apart for any structural defects, anything that might be bad. And you can see a couple of these, they didn't want to come out. I had to take a hammer and kind of tap them out. The pin could be tweaked a little bit, but most of the time what happens is the bore actually in the piston gets tweaked a little bit. But typically, as long as they come out fairly easy and I don't have to put a lot of force on them, I'm okay. There might be some people that disagree with that, and they say you got to slide them out by finger just the way you normally put them in. And then looking real close at this piston, you can see it's got some damage to it. Something when it broke come up and smacked it. And this is piston number 3. So being number 3, I mean, the one I broke was number 6. So this one was pretty far away from it. Some of these dings, just from where the rod come apart and where it was at when it come apart. But if you look down in there at the bosses, I mean, there's no cracks. Everything looks good there. I mean, this is not really compromising. It's a little bit on the pin boss, but you got to look at it too. I mean, there is a risk of this thing pulling out on the when the crank is going down, like on the when it's on the intake stroke. But when it's on the exhaust stroke and the compression stroke, the force is going down. The pin is being pushed this way. So that's where I usually, you know, the cracks would form down in there. But I think this thing's okay. I mean, I'm gonna reuse it. I'll clean it up a little bit with the sandpaper, and we're gonna go to it and reuse it. All right, I appreciate you guys following along with me today. Got these pistons prepped and ready to go almost. Next time we get in here, we're gonna clean them up real good, get the new rods hung on the pistons. All right, guys, I appreciate y'all hanging out. Go fast and get some wind lights. Thanks.